All right, today, guys, we're talking about reference angles. Okay, very important topic that will be helping us kind of dissect the unit circle next week. So we kind of got to figure that out. So reference angle, denoted by theta with an apostrophe, is an angle formed by the terminal side of the angle and the closest part of the x-axis. Okay, so when we look at this first one right here, quadrant 1, right, we've got this angle 46 degrees, right? The reference angle is created from the terminal side back to the closest x-axis. So in this case here, it looks like 40. So it looks like it's just going to be 46 degrees. So we would say theta is equal to 46 degrees given to us minus, in this case, the closest x-axis. So what measure of degrees is that? It's 0 degrees, right? So then our final answer would just be 46 degrees. All right. Okay. Now, 3 pi over 4. So 3 pi over 4, first thing we do is let's multiply that by 180 over pi. Let's change that to degrees first off, to make that a lot easier on us. Give me a second here as I find my key. Oh, it's fine. We can use the calculator as well too. So we'll do 3 pi over 4 times 180 over pi, and that would be 135 degrees. Okay. So when finding the reference angle of this one, we're going to the closest x-axis. So see how this arrow is going down towards this, all right? Remember, what is the negative x-axis equal to? It's a half rotation, right, or 180 degrees. So we're trying to find this distance right here, right? So if this is 135, and then this ends up being final solutions 180 here, we would find our reference angle like this. We would say then this reference angle is equal to 180 degrees minus 135. So therefore, our reference angle is equal to, it looks like 45 degrees. Sorry, 180 minus 135. So 45 degrees. Now we want to change that back to radians because it started in radians. So we're just going to go 45 degrees times 180 over pi. And so that's going to give you I meant to say pi over 180. So pi over 4. So your reference angle then is pi over 4. All right, 253. So 253 is quadrant 3. Okay. So here's my terminal side. So then my reference angle is right here. What is outlined in the pencil? That distance right there. Well, this is 270. This is 180, okay? And we know that this right here, terminal side, is a total of 253. We're going back this way. So how I find the reference angle for quadrant 3 is I take the angle given, whatever is in quadrant 3, and I subtract 180 from it. And when I do that, I find out that my reference angle is equal to 73 degrees. Okay. Last but not least, 7 pi over 4. Again, we're going to multiply that by 180 over pi. All right, and when we do that, we end up with 315 degrees. So in quadrant 4, we're going back towards the positive x-axis here, which by when you do a full rotation is now 360 degrees. So how we find our reference angle in quadrant 4 is we take 360 degrees minus the angle given in quadrant 4. So therefore my reference angle is then equal to 45 degrees. And now that started off in radians, so let's finish changing to radians, which we already just did before the problem above there. And so we know that 45 degrees times pi over 180, because I'm going back to radians, equals pi over 4. Now sometimes we have problems like this where it maybe isn't between 0 and 360. And so we first need to find a positive coterminal angle between 0 and 360. So my first step is taking 487 minus 360. Now I've drawn the picture for you. It's not always going to be drawn. So 487 minus 360. That gives you 127. Okay. And so 127 falls in quadrant 2. So again, how do we find quadrant 2? Because look at, here's my reference angle. Just right there. Okay. We take 180 degrees minus the angle given. And so then my reference angle then equals 53 degrees. Okay. Same thing here. First thing though we need to do is, for F, is we need to change that to degrees. It makes it a lot easier to change it to degrees first. I know it's extra steps, but it's going to make your life a lot easier. So negative 13 pi over 3 times 180 over pi. Again, I'm doing this in the calculator, guys. Doing this in the calculator. Okay. Gives me negative 780. Okay. Well, we're going to do, I think, to get it between 0 and 360 is now I'm going to add that. I'm going to do 3 times 3 revolutions, or 360 degrees. And when I do that, it's going to give me what? So let's do it in the calculator. So negative 780 plus 3 times 360. Okay, 300 degrees. So I get (300 degrees). So then now, because that's in quadrant 4, to find our reference angle, we're going to take quadrant 4, what's the closest x-axis? Right here, guys, right here. Okay, we're going to take 360 degrees, and we're going to subtract 300 from it. And so that gives me then 60. Which then I need to then multiply by pi over 180, which then gives me pi over 3. And so what you guys should notice by now is that reference angles can be up to 90 degrees, but they're always acute and positive. So they're always going to be between 0 and 90 degrees and always positive. Okay? In summary, to find a reference angle based on the quadrant which the terminal side lies, okay, use the rules here. So if we get it in quadrant 1, whatever your reference angle just equals whatever theta is. Okay? In quadrant 2, okay, whatever your reference angle is equal to 180 degrees minus whatever that angle is in quadrant 2. Okay? In quadrant 3, you're taking whatever angle is given to you minus 180 degrees. Okay? And in quadrant 4, you're taking 360 minus whatever the angle is given to you. Okay? I also gave you the rules for radians as well if you'd like to do that. I just find it a lot easier to change to degrees, and then the problems that are given to you in radians you can change back then to radians. Alright? Not a long video today, guys. We'll go over any questions you have in class tomorrow. Thanks, and I'll talk to you guys tomorrow in class. Peace.